I'm bucking deep in Tennessee with my brothers from the 3. We quick to click and break the peace. No respect for what they think.
Yo, what's up everyone? It's Alan Everson and welcome to another video. Now we're here at chapter 9, subnetting IP networks. So we're going to discuss the summary of chapter 9. First, chapter 9, we have the introduction, subnetting an IPv4 network, addressing schemes, design considerations for IPv6, and that is the summary. So, subnetting an IPv4 network. Reasons for subnetting. Subnetting is the process of segmenting a network into multiple smaller network spaces called subnetworks or subnets. Large networks must be segmented into smaller subnetworks, creating smaller groups of devices and services to control traffic by containing broadcast traffic within each subnetwork, reduce overall network traffic, and improve network performance. Communication between subnets. A router is necessary on different networks and subnets to communicate. Each router interface must have an IPv4 host address that belongs to the network or subnet that the router interface is connected. Devices on a network and subnet use the router interface attached to their LAN as their default gateway. So the plan. IP subnetting is fundamental. Fundamental. Planning the network. Planning requires decision on each subnet in terms of size, the number of hosts per subnet, and how host addresses will be assigned. So as you can see, we have illustration here, namely student LAN, faculty LAN, and the admin LAN. So basic subnetting. Borrowing bits to create subnets. Borrowing 1 bit, 2 raised to 1 is equal to 2 subnets. So as you can see, borrowing 1 bit from the host portion creates 2 subnets with the same subnet mask. Subnets in use. Subnets in use. So these are the address range for 192.168.1.0/25 subnet. So this address range for 192.168.1.128/25 subnet. So subnet 0 is the 192.168.1.0-127/25, and the subnet 1 is the network 192.168.1.128/255/25. So there's subnet 0 and subnet 1. Subnetting formulas. Calculate the number of subnets. Subnets equals 2 raised to n, where n equals to bits for borrowed. 1 bit was borrowed, 2 raised to 1 equals 2 subnets. Calculate number of hosts. Host equals 2 to the power of n, where n is host bits remaining. So 7 bits remain in host field. So 2 to the power raised to the 7 equals to 128 hosts per subnet. And 2 raised to 7 minus 2 equals to 126 valid hosts per subnet. Creating 4 subnets. Borrowing 2 bits to create 4 subnets. 2 raised to 2 equals 4 subnets. Creating 4 subnets. So borrowing 2 bits here. Borrowing 2 bits creates 4 subnets. All 4 subnets use the same mask. Borrowing 3 bits to create 8 subnets. 2 raised to 3 equals 8 subnets. Creating 8 subnets continues. So this is subnet allocation illustration. Subnetting based on host requirements. 2 considerations when planning subnets. Number of subnets required. Number of host addresses required. For formula to determine the number of usable hosts is the 2 raised to n minus 2. 2 raised to n, where is n is the number of remaining host bits is used to calculate the number of hosts, and negative 2, the subnetwork ID and broadcast address cannot be used on each subnet. Subnetting network based on requirements. Calculate the number of subnets. Subnet based on organizational structure. Research and development, sales, etc. So 2 raised to n, where is the n is the number of bits borrowed and subnet needed for each department. Subnetting to meet network requirements. Balance the required number of subnets and hosts for the largest subnet. Design the addressing scheme and accommodate the maximum number of hosts for each subnet. Allow for growth with each subnet. Subnetting to meet network requirements. So subnets and addresses. Traditional subnetting ways addresses. Traditional subnetting uses the same number of addresses allocated for each subnet. Subnets that require fewer addresses have unused or wasted addresses. For example, one links only need 2 addresses. The variable length subnet mask, variable length subnet or VLSM. The variable length subnet mask or VLSM subnetting subnet provides more efficient use of addresses. VLSM allows a network space to be divided in unequal parts. Subnet mask varies depending on how many bits have been borrowed for a particular subnet. Network is first subnetted and then the subnets are resubnetted. Basic VLSM. So it is a VLSM subnetting scheme. VLSM in practice. Using VLSM subnets, the LAN and WAN segments in example below can be addressed with minimum waste. Each LAN will be assigned a subnet within /27 mask. Each WAN link will be assigned a subnet with /30 mask. VLSM chart. So VLSM subnetting of 192.168.20.0/24. Addressing schemes. Planning to address the network. Allocation of the network address will be planned and documented for the purpose of preventing duplication of addresses, providing controlling access, monitoring security and performance. Current addresses, usually dynamically assigned using the Dynamic Host Configuration Protocol or DHCP. Design consideration for IPv6. Subnetting using the subnet ID. An IPv6 network space is subnetted to support hierarchical logical design of the network. IPv6 subnet allocation. So use the IPv6 subnetting into the interface ID. IPv6 bits can be borrowed from the interface ID to create additional IPv6 subnets. So for summary, in this chapter you learned that subnetting is the process of segmenting a network by dividing it into multiple smaller network spaces. Subnetting a subnet or using VLSM was designed to avoid wasting addresses. IPv6 address space is subnetted to support the hierarchical logical design of the network. Size allocation, use, and access requirements are all considerations in the address planning process. IP networks must be tested to verify connectivity and operational performance. So that's all for today's video, and thank you for watching.
Bitch, get off of me, I'm fucking deep in Tennessee with my bro.